Hello guys, today we are going to be playing with one of the challenges for the Eximus lab, and I personally find it very interesting because it allows you to get the real system knowledge of the DevOps engineering, right? And it's not something bluff, right? It's just raw engineering skills. These are the skills which actually matters in the real world, right? So let's not waste much time and let's get started. So we have a challenge over here, and it's basically telling us that we have to freeze a process without stopping or killing it, right? So freezing is a complicated term which I am going to explain over here, right? So think this can be useful if you want to temporarily suspend a heavy job during a peak load, hold a server still while you still reconfigure the environment, or stop the worst so you can inspect the system state or like for the system security audit, right? So basically what it is trying to tell us is that you have a process, you need to freeze it up. This process might be eating a lot of memories in our system, right? And when it is eating a lot of memory, we might need to take a pause over here. We might need to freeze that given process and be like, okay, you're frozen now, and I'm going to inspect my own system state at this given point and see where the investigation leads us, right? So yeah, that's pretty much about it. So the folks who don't know what's the central groups, which is the C group is. Now, basically, C group allows the kernel to group processes under hierarchy, right? So we might have different processes. I think so. It's not present over here, but think of it like we have different processes, and we can club these processes under a single hierarchy, and we can apply some resource control on top of it, like limiting the number of CPUs, memory, IOs to the whole group, right? So instead of if I can draw, so think of it like we have PID, we have one process PID 0, no, not PID 0. Okay, PID 10, PID 11, and PID 23. So all of this process, have created a logical group for this thing, and which I name it as C group, right? And for it, I'm going to apply some resource control to specify how much CPU can be allocated or memory can be allocated and so on to this whole group, right? So eventually we are taking care of this whole group itself over here, not a single process over here. So yeah, so far now I think so good. And if we want to see, the thing is that all of the C groups are present as part of the sys call, right? So let me just quickly show you where it is that. Yeah, so we are in the C group, and you can pretty much see that we have a couple of C groups over here, and these are the basic. If you want to explore, you can keep on exploring these things, and I think so in the lab also they have specified that. So eventually you can see that there is a C group controller which has been specified over here. So yeah, that's which list all the controller available in the child C group, right? And then there is CPU controller. So your CPU controller, CPU max state, and the max and where is a max? Yeah, CPU max might be here. CPU dot stat is here, and CPU dot max will also be somewhere here, right? I can't find it right now. So eventually we have the CPU controllers as well over here, when we have a CPU IO controller which limits the maximum usage, right? Oh, sorry, which we can limit the CPU usage to 50%, and then we have memory usage as well. So all of this given operation can be applied to the whole C group itself over here, right? And that's a pretty interesting thing, right? So uh, what eventually happened, just to cover the basic, a C group is a directory under which it groups processes and exposes control files, like, so basically it is a directory and it exposes couple of the files which has been specified over here, right? So let's go ahead and start so the question says that, so the challenges states that you have been provided some simple program that greedily consumes CPU and memory when started. So let's see. Let's start this given OmniHawk. So when we started this OmniHawk, you can clearly see that it started a CPU hog and it's continuously allocating 10 MB of memory, right? Right now it seems like okay, it's not much, but after a certain point, you will start to realize that it will end up consuming all of your RAM. And that's when you're going to start hitting the problem itself. So hats off to the developer. I don't know how the developer managed to pull this off. I hope so. It's not a real memory which gets allocated. Otherwise, the person would have to pay a really, really expensive AWS or like wherever this site is hosted, right? So yeah, that pretty much covers much about it. So let's try to find the ID of the C group itself over here, right? So we might need to check the ID. So I'm not sure what was the command. Aux something like this. Let's see if there is an ID. Yeah. So you can clear for right now. Okay, let me grab do this. Right now, you can clearly see that the process, the PID, which is associated to the OmniHawk process, which has initially started and it's consuming our RAM, is 3244, right? And uh, we need to, first thing is that we need to create our own C group over here, right? So let's go ahead and create our own C group over here, and let's see how we can create a C group itself, right? So we can basically use C sudo mkdir and omnihawk dot slice, right? When we do this, you can eventually see that again a C group has been created for with the name of omnihawk, and slice is just systemd related stuff which follows some conventions for resource grouping, right? And it's just a directory name representing the C group that we want to manually control. And you can clearly see over here, this is the OmniHawk C group, right? OmniHawk dot slice. And we can see that this given thing has its own everything over here, basically. Memory, CPU weight, CPU starts, max, and everything over here, right? So, since this part is pretty much covered, now our only job is that we need to attach this given we need to attach this given thing to our C group procs. Basically, we need to write this thing. So right now, this process is just a freelance, like it's not on any C group. So let's go ahead and try to attach this thing under a C group. So let's see. So the PID, as I had mentioned, was 3244. So 3244, and let's try to write this thing. C, C group omni hawk dot slice, and we are going to write this in a C group procs, right? Where is our C group procs? So this is the place where we need to keep on if we need to attach any given process, we can pretty much do it in the C group hogs itself, right? So I hope so. I'm pretty much making sense at this point. So if you're new to this, you can clearly refer to these things, right? So this given image actually shows you that you can change the memory max over here. You can change the memory max from 500 MB to something more, right? And let's say that when we created a process. So right now, okay, let's figure this thing out. What is our memory max over here? It's actually fun to play around with this thing, right? And there is a memory max, and let's see what is the output. So it's just a max value. So let's go ahead and allocate assign some memory for this thing, right? To ensure everything is as expected, right? So we have called this omnihawk dot slice, and this is our memory max. Okay, permission denied. Let's see if this is gonna work or not. Hey, what happened to my? Okay, let's. What was the command to just go back to the at the speed I could have eventually write my own things. So yeah. Let's see. No such file directory. Okay. Omnicog. Sometimes I miss, right? So I think so. Right now we might not have that permission to modify. Maybe we do not have the permission. Maybe some cell scripting issues, but who cares? So okay, but eventually if you are the admin, right, you can eventually create your own C group. You can allocate some memory to it, and you can pretty much play around it. Let's give me one more try. So let's start to write 500 M on this thing, sudo t sys fs c group omnihawk slice and memory dot max. Yep, yep, that's how you do it. So eventually you can use this also, dude. This is just a pipe operation where you just write to that given memory dot max, and you can clearly see over here that it's now being updated with 500 MB. So yeah, that's pretty much about it. So once we have completed the OmniHawk slice, we can go ahead and play some more, right? We can try to add that given C to this C group itself. We wanted to add a process. Hey, what was the ID? 3244. So let's go ahead and add this 3244 slash sudo t sys fs C group, and let's add the Omniong slice and C group. Come on, dude. C group rocks. Yeah. Okay. We have added it to a C group. And yeah, we have gotten a hooray. Something to be happy about, right? So yeah, let's just not get too ahead of ourselves. Right now we need to pause this thing, right? We want to freeze this thing, and let me see what was the command to freeze it up. I'm not sure. Like, I'm trying this for the very first time itself. So okay, we have that everything. So we have the hint as well over, okay, that's good enough. But I remember that somewhere over here we need to pause that given program. We can just write one to a given file, and eventually this will result in stopping that given thing. So freezing can be okay. Okay, this thing is that, so okay, something happened. Bad happened. Oh, this program has been killed. Oh, this program got killed. We can continue it, dude. Don't worry. Something happened because I told you, right? This is, oh, since we were talking for a very long time, eventually, this program had been killed off. And it makes sense also, right? I mean, we need to do it pretty quick because it's trying to consume a lot of memory. Let's try to do this again and see it's if it's under the same no, it's now under the different name. So let's go ahead and add this given process 7965, and yeah, let's try to input it to the C group T itself over here. So yep, pretty much we have added it again, right? So the process is not running or has been restarted, so you must restart the Omni Hawk process or let it be. So right now it's we started another process over here, right? This one, the previous process might just exist, but it has been killed, and it the state might exist in the process table itself over here. So I'm not going to deep dive much into it, but eventually, now let's try to stop this given process before it gets out of hand. So one way is that we go to the C group and we go to the OmniHog and we go to the C group. Okay, how do we do that? Okay, we write one to the C group freeze. Okay, so C group dot freeze, right? So once you do it, right, I think so. I'm not going to get a bonus point for this thing. Once you do this, eventually, what you can see over here is that the process gets thawed over here. Okay, the process has been thawed. Like, okay, the process has been paused. I'm sorry, my bad. Thawed is like I got that different feeling. But anyways, you can see that the process is eventually not running. right? And if you're confused that whether it's I'm saying true and false, you can just pretty much figure it by this itself, right? So I will try to again unfreeze it. So again, if I write 0 over here, right? So you can see that the process has been killed over here. Oh, so right now the memory consumption is pretty high, so that's one of the reason why this thing is causing some problem. But eventually, I hope you got the gist that we are pretty much freezing all the processes in C group by simply writing one, and to thaw the process, basically to resume the given process back to its state, we write 0 itself over here, right? So this is one of the interesting things, and if you want to explore further, the thread does not uh, the state which eventually lands up for this given process is that it does not move any makes any forward progress, right? So it might they might it does not make any while it's frozen, it does not make any forward progress. So that's pretty much it. So you can inspect the process memory, the CPU usage while frozen, right? So that's pretty interesting thing for this, right? So when we talk about this thing, I just wanted to tell a couple of more things, guys. So this is something which is not covered as part of the series, but I want to share with you. So eventually, this is not the only way. So let's say that I can eventually use a kill to stop the given process. And okay, first let's get the process ID again back. So the process is what was the process, dude? It's not the same process anymore. Yeah, let's get the process. So eventually, if I do a kill stop and we provide the process ID to it, for example, 808011. So eventually, you can see that the process gets stopped over here, right? And at this point, also, you can pretty much inspect the memory. You can check the CPU usage, process memory. You can pretty much do everything, right, for this given process. So you might ask me that what is the benefit of actually using a C group over here, right? I mean, simply we could have just used a skill switch and we could have stopped it and do the same. Now, let's say that I want to resume. I can just provide a cont and I can just provide the process ID name again, process ID number again, and it's just resuming over here, right? Let's try to stop it again. Okay. So when we try to stop it, it's working as pretty much the same, right? Same thing as the C group itself. So guys, let me tell you the benefit which we eventually get from the C group itself is that we can list we can add lot of processes under this C group, right? And for the when we talk about the hierarchy, right? When we talk about the direct like these whole process PIDs, what eventually happen is that we can limit the IOPS or the CPU or the memory related thing for this entire PIDs. So that is one of the given benefit which can eventually happen for this thing, right? So yeah, that's pretty much about it. I hope you liked it, right? So yeah, that's all from me. Thank you.